Okay, for this last video on the retest review for exponential models, solving equations, and finding inverses, we're going to be focused on finding inverses and solving equations. Going to have our calculator, but need to recognize how to do some of the work without a calculator. So let's say that we have this rational function and we want to find the inverse of the function. The first thing that we do when finding an inverse is to interchange x and y. So let's say that we had this set up as a y equals. We would interchange x and y and say x is going to be equal to 2y plus 3 over 5y minus 7. Then we'll multiply both sides by 5y minus 7. So we have x times 5y minus 7 is equal to 2y plus 3. All right. The next step is to go ahead and distribute. And I'm going to have 5xy minus 7x is equal to 2y plus 3. All right. To find the inverse, after we've interchanged x and y, we want to isolate y. So we're going to rewrite our equation to move our y's to the same side of the equation, or our x's, everything without y, to the other side of the equation. So we'll be able to say 5xy minus 2y is equal to 3 plus 7x. All right, and now let's factor out a y. So y times 5x minus 2 is going to be equal to 3 plus 7x. And so our last piece is to get our solution that if we were to solve, that's going to be our inverse. And that's going to give us 3 plus 7x in the numerator and 5x minus 2 in the denominator. All right, so step one, we interchange x and y, right? And after interchanging x and y, then we can go on to step 2, step 3, step 4, step 5, and then our final step, step 6, if we're going to find the inverse of a rational function. Now, what if we didn't have a rational function? What if we had an exponential function? We can still approach in much the same way. We can interchange x and y. So we could say x is going to be equal to 2 times 3 to the y minus 1 plus 5. Let me subtract 5 from both sides. That means that x minus 5 is going to be equal to 2 times 3 to the y minus 1. Let me divide both sides by 2. So x minus 5 divided by 2 is going to be equal to 3 to the y minus 1. Okay. Then how do I undo, right? How do I undo an exponential? I can work with the same base, so log base 3. But if I do it to one side, I need it to do to the other side. So I'm going to do log base 3 to both sides of this equation. So that's going to give me that y minus 1 is going to be log base 3 of x minus 5 all over 2. And I want to get to my inverse, so the last thing to do is going to be to add 1 to both sides. So my inverse of g is going to be 1 plus log base 3 of x minus 5 all over 2. All right, and so there I have my inverse, which once again started with interchange x and y if I want to determine the inverse. Okay. Our next equation, we have negative 3 log base 5 of 4x plus 9, right? So if I'm going to interchange x and y, that's going to say x is equal to negative 3 log base 5 of 4y plus 9. That's step 1. Okay, let's divide by negative 3. So negative x divided by 3 is equal to log base 5 of 4y plus 9. Okay, undo a logarithm by exponentiating. So that means that 5 raised to the negative x over 3 is equal to 4y plus 9. Okay, subtract 9 from both sides. That means that 4y is equal to negative 9 plus 5 to the negative x over 3. And lastly, I get to my inverse, that the inverse of h is going to be negative 9 plus 5 to the negative x over 3, all of that divided by 4. All right? And so there I have my solution. They are multiple steps. You got 4, 5, 6 steps to solve. You have to be careful in the work, right? But it is what it is. It always starts with interchanging x and y. Okay. Now, let's look at our next set of equations. We have a set of equations, some involving exponential functions, some involving logarithms, and we want to solve algebraically to provide exact solutions. So you kind of need to pretend that you don't have a calculator. So for the first one, we should recognize that both of these have a common base of 4, so I could say 4 to the 3x minus 5 is equal to 4 to the negative second, which means that 3x minus 5 must be equal to negative 2, which means that 3x must be equal to 3, which means that x has to be equal to 1. And that's my solution. If I look at the next problem, I have 9 raised to the x plus 1, 27 raised to the 2x. I can see both of these are base 3, so I have 3 squared raised to the x plus 1 is going to be equal to 3 cubed raised to the 2x. Properties of exponents, I can multiply the exponents, and so that gives me that 2 times x plus 1 must be equal to 6x. So 2x plus 2 must be equal to 6x. Right? So then that means that 2 must be equal to 4x, so x must be equal to 1/2. All right? Solving equations algebraically using exact solutions. For logarithms, here I have the same base of 7 for each, and apparently I have a typo over here. This should say log base 7 of 15. We'll get that corrected. All right, so I have base 7 for each of these, so that means that x times x minus 2 must be equal to 15 because of my properties of logarithms, which means that x squared minus 2x minus 15 must be equal to 0, which means that x minus 5 times x plus 3 must be equal to 0. From my domain restriction, I know that x has to be positive because I have log base 7 of x, and so that means that x equals 5 is the only solution. Because that, if x was negative 3, I would have a domain issue. So properties of logarithms, remember, we do have them listed up here. Properties of logarithms, if I have addition of 2 logarithms with the same base, I can work with multiplication. Okay. Then for this final set of questions, we're going to rewrite each equation using log or exponent properties. Then we're going to solve for x to 3 decimal places. All right, so we'll use our calculator once we set it up. So if I'm going to rewrite this using exponential or log properties, what that means is over here, I can take the logarithm base 2 of both sides of this equation, right? Logarithm base 2 to both sides. That's going to give me 3x minus 1 equals log base 2 of 81. Right? Then I can use my calculator to solve. Right? One way that I could do it is to say, hey, I have a logarithm, change that base to base 2 of 81. That's a number. To that, I'm going to add 1, and then I'm going to divide by 3, and so I would get that x is approximately 2.447 to 3 decimal places, or I could leave it as 2.446 if I didn't want to round. Right? Because it says solve to 3 decimals, it doesn't tell me whether or not I need to round. Right? I could, of course, with numworks, go to my equation solver and type that in. I've got 3x minus 1. Oops, let's go. 3x minus 1 is going to be equal to, right, my logarithm of 81. But remember, it's logarithm base 2. So I need to make sure that I adjust that logarithm to be logarithm base 2. Solve the equation. We get an exact solution, and we see the decimal solution as well. All right. Properties of logarithms. If I look to this next one, I have two different bases that I have x in the exponent. I just need to select one of them to use to do my evaluation. And so I'll come over here and say log base 3 to both sides. Okay, so what does that mean? If I do log base 3 with the base of 3, that means that x plus 1 is going to be equal to 2x log base 3 of 5. Right, now I'm trying to solve for x, so that means that 1 is equal to 2x log base 3 of 5 minus x. Right, so there is properties of logarithms that I could work with. Right, but really I want to make sure that we understand and that we can get to that first step there. And if I have my equation solver, I can put from that first step, x plus 1 is equal to, right, 2x, right, because I can take the exponent, bring it to the front of my logarithm. So 2x log of 5, but I need to make sure I adjust the base. So 2x log base 3 of 5, and say solve this equation, and it gives me an approximate solution, which is to 3 decimal places 0.518. So since it doesn't say to round, I don't need to. And of course, for this particular one, there is not rounding. Right? If I was going to do it by hand, can go to my calculator, right? And I would say, hey, I have 2 times x times log base 3 of 5 minus x. So really, if I said 1 divided by everything that's a coefficient of x, which would be 2 log of 5, all right, close that parentheses, but we know it's a base of 3, so 2 log base 3 of 5 minus 1. And if I look to that, I get that same solution, the 0.518, right, that I could have just factored the x and divided. Okay. Then for the last equation, properties of exponents or logarithms, if I have subtraction, it's division. So this tells me that x over x minus 5, right, because I have an implied base of 10 for each of these. So x over x minus 5 must be equal to 20, right? If I come to my equation solver, x divided by x minus 5 must be equal to 20. Solve the equation, and it tells me that x is approximately 5.263, going to 3 decimal places. If I was going to solve by hand, I would have x equal to 20 times x minus 5, which would mean that x is equal to 20x minus 100, which would mean that 100 is equal to 19x. And if I do on my calculator 100 divided by 19, I get that 5.263. Okay, so solving equations is kind of the bread and butter of algebra and of pre-calculus. It tends to be what makes advanced mathematics difficult is really the algebra aspect of it, right? Advanced mathematics really looks towards how can we use patterns and properties to simplify our work, but sometimes we just have the algebra that we need to be able to do, we need to be able to do correctly, and if it takes practice, it takes practice. All right. Thank you very much for your time.